Everyone, my name is Min and today I'll be presenting my Data 670 Capstone project on employees retention analysis in the defense industry. Unlike other sectors, turnover in defense isn't just about hiring someone new, it's about replacing highly specialized roles that require extensive security clearances and years of experience. Imagine you have a mechanic who had been working on a B 2 bomber for a long time. He knows the nuts and bolts of the engine, when to tune and when to knock. All of a sudden, he decides to quit the company. Losing these employees means losing institutional knowledge, increasing recruitment costs, and disrupting operation. This project explores how data-driven strategies can predict attrition risk and help HR team to proactively retain employees. We can move from reactive hiring to predictive workforce management, saving organization millions in cost while improving workforce stability. The goal is to focus on analyzing employee attrition in the defense industry using data analytics. High turnover in this sector leads to costly hiring processes, weaker workforce stability, and loss of expertise. Unlike the other industries like fast food restaurants, you could simply get someone off the street and flip a burger in most cases, but replacing an employee in defense sector, especially in aircraft maintenance, can take months, if not years, because of security clearance requirement and specialized trainings. The goal of this project is to predict which employees are at risk of leaving and why. Using machine learning and data visualization, we can identify key trends in attrition, create predictive models, and develop HR-driven solutions to improve retention. Instead of relying on outdated HR methods, we can use data science to have a smarter workforce decisions. The defense sector is facing serious retention issues. A 2022 study found that 78% of defense companies lost employees to higher paying jobs, while the US Army missed its recruitment goals by 15,000 soldiers in 2023. This workforce crisis is impacting both military and civilian defense roles, making retention a top priority. The problem isn't just about pay, it's about job satisfaction, career growth, work-life balances, and high-stress environment. Traditional HR approaches aren't enough. Predictive models allow us to anticipate attrition risk early, helping HR teams to make informed decisions before employee leave rather than reacting afterward. To tackle this challenge, I structure my analysis into five key phases. The first is data cleaning and preparation, where I remove missing values, standardize jobs roles, and ensure dataset consistency. Clean data is essential for accurate predictions. The next is EDA, where I examine trends in job satisfaction, compensation, commute distance, and overtime hours to understand key attrition patterns. Then predictive modeling, where I apply machine learning techniques like logistic regression, decision trees, and random forests to identify which employees are most at risk of leaving. The fourth is visualizations and insights, where I create heat maps, trend graphs, and interactive dashboards to help HR team interpret the finding easily. Finally, I provide actionable HR recommendations such as optimizing base structures, improving work-life balances, and offer career growth programs to help with retention. Past studies have used IPM HR Analytics attrition dataset to analyze workforce trends, identifying job satisfaction, compensation, and work-life balances as key attrition drivers. However, these studies don't account for industry-specific factors in defense like security clearance delays and classified project requirements. This project fills that gap by integrating a defense-specific HR dataset which includes variables like military versus civilian jobs roles, security clearances, security clearance status, and deployment frequencies. This makes sure that the analysis reflect a real-life challenges in defense workforce, leading to a more targeted and effective HR solution. Before running the analysis, I anticipated that job satisfaction would be the strongest predictor of attrition, as unhappy employees are more likely to leave. I also expected that insufficient pay raises and high overtime workloads would increase turnover, with employees seeking better compensation and work-life balance elsewhere. Additionally, I predicted that long commutes would contribute to attrition, especially for employees traveling more than 20 miles daily. Lastly, I expected that limited career growth would be a significant factor, as employees with no advancement opportunities often look for jobs elsewhere. My goal is to achieve at least 85% precision in predicting attrition rate and to help the HR make a good decision. To evaluate the success of this project, I defined four key KPIs. First, attrition prediction accuracy, which ensures that machine learning models reliably predict who is at risk of leaving. Second, retention rate improvement, measuring how well the recommended strategies help reduce attrition. The third KPI is the employee satisfaction increase, tracking improvement in job satisfaction through engagement programs and career development. Lastly, recruitment cost reduction, especially as estimating how much organization can save by lowering turnover and minimizing hiring and training experts. Let's go over the data. This project this project combines two datasets: the IPM HR Analytics Employee Attrition datasets, which include 1,470 employees' records and cover job satisfaction, salary, and work-life balance, serve as the baseline. However, the defense workforce retention involve unique challenges, so I incorporated the assimulated defense HR datasets, which include security clearance level, deployment frequency, and military versus civilian roles. This combination ensures that the analysis reflects both general attrition trends and defense-specific workforce reliability. The IPM dataset provides insights into general workforce attrition, while the defense dataset introduces sector-specific factors that traditional HR studies overlook. Key common attributes include job satisfaction, salary, and overtime hours, while defense-specific attributes such as security clearance and employment frequency add a deeper layer of analysis. These structures allow for more targeted understanding of why employees leave the defense. The IPM dataset offers a validated benchmark for attrition analysis, but it doesn't account for classified nature of the defense work. Many HR studies don't consider security clearance delays, frequent relocations, or specialized technical roles, which significantly impact attrition in this sector. By integrating the simulated defense dataset, the analysis is more realistic and applicable to military and contractual workforce planning. This approach makes sure that the findings address the actual workforce challenge faced in national security and defense operations. To merge these datasets, I follow a four-step integration process. First, I identify common attributes such as job satisfaction and salary, allowing for direct comparison. Next, I map defense-specific factors like security clearance and deployments to better capture industry-specific retention risk. I then standardize categorical variables to ensure consistency across both datasets. Finally, I clean and preprocess the data, removing missing values and normalizing features. This integration provides a comprehensive data set for training predictive models and generating meaningful insights for HR teams. With data integration complete, the next step is exploratory data analysis (EDA) to uncover patterns in attrition risk factors. Following that, I will develop machine learning models such as logistic regression and random forest to predict which employees are most likely to leave. The final phase involves translating these insights into practical HR strategies, focusing on improving employees' engagement, adjusting compensation structures, and enhancing career development opportunities. This data-driven recommendation will help defense organizations reduce attrition, save costs, and strengthen workforce stability. As I finalize my analysis, my focus is on ensuring that the insights are practical and actionable for defense organization. And I would love to hear your feedback, what you feel like. Feel free to comment, like, and subscribe to my YouTube channel for more discussion on how data science is transforming workforce management. Thank you to listen to my YouTube channel.